Welcome to NEETshala Organic Chemistry Revision Lecture Series. In this lecture, we will be discussing the chapter of amines. So let's get started with the chapter. What are amines? Amines are basically considered as the derivatives of ammonia. These are the derivatives of ammonia, and these are obtained if we remove one or two or three hydrogen atoms of ammonia with alkyl groups. That means I can either remove this hydrogen or I can remove this hydrogen or this or all the three. I will be getting an amine if I substitute a CH3 group at all these positions. So that is known as amines. So let us now talk about the next one, structure of amine. So it is almost similar to the structure of ammonia, where the nitrogen atom is trivalent and it carries unshared pair of electrons. Nitrogen orbitals in amines are therefore sp3 hybridized. That is important. It is sp3 hybridized, and the geometry of amines is going to be pyramidal. This is important. The shape is pyramidal, and each of the three sp3 hybrid orbitals of nitrogen overlap with the orbitals of hydrogen or carbon depending upon the composition of the amines. The fourth orbital of the nitrogen of all amines, they contains an unshared pair of electrons that we already know from the structure of ammonia. It's almost similar to the structure of ammonia, but there is slight difference, like the bond angle is slightly different. In the case of trimethylamine, we are having a bond angle of 108 degree, and in the case of other, we are having less than 109.5 degree because of the unshared pair of electrons. It is slightly deviated from the tetrahedral angle. Let us now talk about the classification of amines. We have already studied this in previous chapters also. We have ammonia, and if I remove one of the hydrogen and substitute an R group over there, we are getting a primary amine. And if I am removing two hydrogen and substituting two alkyl groups, then I am getting a secondary amine. And if I am removing all the hydrogen of ammonia and substituting it with alkyl groups, then I will be getting a tertiary amine over there. Let us now move on to the next slide. Preparation of amines. So let's start with the first method of preparation of amine. The first one is by the reduction of nitro compounds. So how can we prepare amines by the reduction of nitro compounds? It's very easy. If we have nitro compounds, we can use finely divided nickel, palladium and platinum, and we can pass hydrogen gas. Hydrogen in the presence of platinum, palladium, nickel. That is the first method. Second method is by the reduction with metals in acidic medium. Okay, so here we can see Sn plus HCl or Fe plus HCl. That can also give us NH2. So NO2 group is converted to NH2 group. The process is called as hydrogenation, or we can say it is reduction of nitro compounds. Let us now see the second method. The second method is known as ammonolysis. Now what is ammonolysis? It is the process of cleavage of CX bond by ammonia molecule. If we have CH3X, we are going to break this bond by using ammonia. That is known as ammonolysis, and here NH3 is going to act as a nucleophile. That is the important point over here. The primary amine that's obtained behaves as a nucleophile in the second case. So now this RNH2 can react with another molecule of Rx. So I'll just remove this. Okay, so here you can see that the RNH2 is going to react with Rx. So here RNH2 can now act as a nucleophile. So that can react with the Rx to form R2NH. This R2NH can now act as a nucleophile, and that can react with an Rx to form R3N. Now this R3N can also act as a nucleophile, and it will react with Rx to form R4NX. That is known as quaternary ammonium salt. So this is known as quaternary ammonium salt. This formula is important. And how to get free amine from that? How to get amine from quaternary ammonium salt? The method is very simple. We can treat it with NaOH. If you're treating the quaternary ammonium salt with NaOH, we will be getting RNH2 plus H2O plus NaX. It's very simple, right? Let us move on to the next slide. This is the disadvantages of ammonolysis. So I'll give the heading disadvantages. Now when we talk about the disadvantages of ammonolysis, it has a disadvantage of yielding a mixture of primary, secondary and tertiary amines and also quaternary ammonium salts. Okay, but the merit is that we are getting primary amine as the major product if we take large excess of ammonia. And what is the reactivity order? The reactivity order is coming out to be Ri greater than Rbr greater than Rcl. This is the reactivity order. Let us now talk about the next method, that is the reduction of nitriles. So whenever we have nitriles, we have to use hydrogen in the presence of nickel, or we can use sodium amalgam in the presence of ethanol. Both of these can convert the Cn group into CH2NH2 group. So here we can see if we have CH3Cn, it is converted to CH3CH2NH2, right? So here we have 2 carbon and here also we have 2 carbon, right? But see here, the reaction is used for ascent of amine series. This particular reaction is used for ascent of amine series. That means if we have 2 carbon over here, we have to get 3 carbon over here, right? Because the R group will have only 2 carbon, right? Here the R group will have only 2 carbon. And another carbon is from the cyanide group. Now that is also going to go with the R group. So in the case of the R group, one more carbon is getting added, and that is why it is said that it is an ascent of series. So what are the reagents that is used? H2 in the presence of nickel, or we can use sodium amalgam in the presence of ethanol to convert nitrile to amines. Let us now talk about reduction of amides. So for reduction of amides, we can convert it by using lithium aluminum hydride and water. This simple reaction. So this is corresponding, right? Because here if we have 5 carbon, here also we will get 5 carbon. The same number of carbons will be there. But we have another method that is known as Hofmann bromamide degradation. There this CO group will be removed. So that is a descent of series. Let us learn about that now. Before that, we have Gabriel thalamide synthesis. Now what is happening in Gabriel thalamide synthesis? This is used for the preparation of primary amines. This is an important point. It can be used only for the preparation of primary amines. Thalamide on treatment with ethanolic potassium hydroxide. What is that? KOH. It is basically KOH. So this is our thalamide molecule. Yesterday we studied how to prepare thalamide and we have to treat it with KOH. At that time what is happening? This H from here is going to be as water and this K will get substituted over here. So this is what we are getting over here. Now what we should do, to this compound we have to add Rx, right? Because this one is now going to act as a nucleophile. So this reaction will lead in the formation of N-alkyl thalamide. That means the K should be substituted with R. Now this is treated with NaOH. When this salt is treated with NaOH, what is happening? Both these compounds are broken and that is going to form an RNH2 and we get this byproduct over here. So this is used for the preparation of primary amine. So first step we will use KOH, second step we will use it RX, and the last step we will use NaOH. So this is how you have to remember this reaction. Most important point is this: aromatic primary amines cannot be prepared by this method. What is the reason? Because aryl amines do not undergo nucleophilic substitution with the anion that is formed by the thalamide. That is this portion. This reaction will not occur. Okay, this part will not react. That is the reason why it is not used for the preparation of primary aromatic amines. Let us now move on to the next reaction. Yes. So the next reaction is Hofmann bromamide degradation reaction. So when we talk about HBD reaction, we can abbreviate it as HBD reaction. So what is happening in HBD reaction? Hofmann developed a method for preparation of primary amines on treating an amide with bromine in aqueous or ethanolic solution of sodium hydroxide. Here you can see Br2 plus NaOH is the main reagent for bromamide degradation reaction. So here what we should do, we are removing the CO group and whatever is left we will just join to get the amine. So we can say this is 1 carbon less than that present in the amide. So it is a descent of series. It is a descent of series. So let us move on to the next slide. That is the physical properties of amines. The first one is the color and state. Lower aliphatic amines are gases with fishy odor. Primary amines with 3 or more carbon atoms are liquid and still higher ones are solid. Aniline and other aryl amines are usually colorless but get colored on storage due to atmospheric oxidation. So that means if we are keeping it in air, what happens is that they get colored, usually a brown color. brown or reddish color it is obtained over there. Let us now talk about solubility. Now, lower aliphatic amines are soluble in water. What is the reason? It's because they can form hydrogen bonds. However, solubility will decrease with increase in molar mass of the amines. What is the reason for that? Because as we increase the number of carbon atoms, what happens is that the size of the hydrophobic alkyl part का size increase हो जाता है, and as a result of which the solubility is going to decrease, because solubility, as we know, is inversely proportional to hydrophobicity, right? Hydrophobicity, inversely proportional to hydrophobicity. Higher amines are essentially insoluble in water due to the same reason. Amines are soluble in organic solvents such as alcohol, ether, and benzene. So the most important point over here is this. Let us now talk about the boiling point. Now, when we talk about boiling point, primary and secondary anilines are encased in intermolecular association due to hydrogen bonding between the nitrogen of one and hydrogen of the other. That means there is intermolecular hydrogen bonding. That is the important point. Due to the presence of this intermolecular hydrogen bonding, there can be very high boiling point. And the order of boiling point of isomeric amines is following this order: primary greater than, secondary greater than, tertiary. This order is very, very important. Tertiary does not have intermolecular association due to absence of hydrogen, and as a result of which they are having minimum boiling point. Let us now talk about some of the important distinction tests. First one is the carbyl amine reaction. Now, when we talk about carbyl amine reaction, we have to study the reaction first. RNH2 plus CaCl3 in the presence of KOH will give us RNC, that is isocyanide. We are getting isocyanide over here along with KCl and H2. So that will give us a foul smell. So this smell will help us identify whether the reaction has happened or not. Is that here we can see, yes, so here you can see one important point, that is secondary and tertiary amines do not show this reaction. This reaction is known as carbylamine reaction or isocyanide test and is used as a test for primary amines only. So aliphatic and aromatic primary amines, they will give the positive result for this reaction. So near to every test we have to write which compound is undergoing this reaction. So when we talk about carbylamine reaction, we have to write that it is only for primary, aromatic and aliphatic amine. They will undergo this particular reaction. Now, when we talk about next test, that is known as Lieberman's nitroso test, reaction with nitrous acid. Here also we can see that the primary aliphatic amines is undergoing the reaction. It is same as diazotization. We get ROH in the final step. Here we get N2Cl and that on treatment with water will give us ROH. Here we have aniline, that also will give the same result as we expect from diazotization. So this is also given by only primary, aliphatic and aromatic amines. Secondary and tertiary reacts with nitrous acid in a different way. So that will give different products. So we can easily identify the products over there. Now, if we have to know how can we distinguish between a secondary and a tertiary, we have to carry out this test, aryl sulfonyl chloride test. So here what we have to do, this reagent is known as Hinsberg's reagent. So this test is known as Hinsberg test. So what we should do is we have to treat the primary or secondary amine with this compound, and then we will be getting this compound over here, that is soluble. So primary and secondary is soluble in this particular compound, whereas tertiary is not soluble in benzene sulfonyl chloride. So this is used for distinguishing between primary, secondary and tertiary. Only primary and secondary will react with aryl sulfonyl chloride and tertiary will not react with aryl sulfonyl chloride. So that is the important point. So you have to understand that the first test that we studied was carbylamine test. So in carbylamine, it was given by primary only, nitroso test, primary only, aliphatic and aromatic. And the last one was Hinsberg's test. Hinsberg's test was given by primary and secondary. So tertiary will not undergo any of these reactions, so we can distinguish them very easily. So if we have a secondary, first carry out carbylamine test. If it is giving a negative result in the carbylamine and a positive result in the Hinsberg test, then we can conclude that it is a secondary amine. Let us now talk about the next one, that is about the tertiary amines. Tertiary amines do not react with benzene sulfonyl chloride. This is a very important point. And also aromatic will not react with benzene sulfonyl chloride. Next is about the basicity. This is very important. The basicity orders. In gaseous phase, the order is tertiary greater than, secondary greater than, primary greater than NH3. This is the order. We have to by heart this order. But in the case of aqueous solution, this is in the case of aqueous solution. So in the case of aqueous solution, we have to study the order as secondary, then tertiary, then primary, and then ammonia. So in the case of ethyl substituted amines, it is STP, that is the decreasing order, and here it is SPT. The primary and tertiary will be just the ulta. So that will be the order for secondary and secondary amines. Next, let us talk about the effect of substituted anilines. So here we can use the same trick that we studied before, which has a dumb dog. So there we have studied that withdrawing group will increases the acidity. So we can say withdrawing group will decreases basicity, just the opposite, right? So if we have electron withdrawing groups, they are going to decrease the basicity, and donating groups or releasing groups, they are going to increase the basic strength. So this is important. Let us now talk about the next one, that is the electrophilic substitution reaction. The first one is bromination. So here what is happening, aniline reacts with bromine water at room temperature to form 2,4,6 tribromoaniline. That means ortho and para positions are substituted at the same time. So at that time, what is happening, we get a product like this. But if we have to get only one product at a time, then what we should do, first step is we have to treat it with CH3CO twice O, that is known as acetic anhydride, and whatever product that we are getting over there, treat it with Br2 in CH3COOH. We will be getting this as the major product, and that on hydrolysis will give us 4-bromoaniline. So this reaction you have to by heart. Sometimes they can ask, how can we get this single product? Let us now talk about nitration. Now what happens in nitration? In nitration also we get a mixture of products. We get para, ortho and meta also, right? But here ortho is minimum, just 2%. Meta is 47 and para is 51, right? So if we need to get para only, here also we have to first treat it with CH3CO twice O, and then we have to carry out the nitration again, and then we have to carry out the hydrolysis. We will be getting para nitroaniline alone. Let us now talk about sulfonation. So when we talk about sulfonation, also we are getting something different. First we will be getting NH3HSO4, that on strong heating we will get sulfanilic acid, and this can exist in a Zwitter ion form, which you have studied in bio as well. So the H will move over here, the H plus will move over here, so this side will get a positive sign and this side will get a negative sign, but overall the molecule is neutral. So that is not a Zwitter ionic form. Let us now talk about Friedel-Crafts acylation and alkylation reaction. Aniline does not undergo Friedel-Crafts alkylation and acylation reaction. What is the reason for this? Because the salt formation with aluminum chloride. Okay, so the NH2 group that will reacts with the AlCl3 group and it will form a salt. So it will not carry out further reaction and it is acting as a very strong deactivating group for the further reaction. The nitrogen of the aniline is going to be a very good deactivating group, and as a result of which it does not carry out Friedel-Crafts reaction. Let us now talk about diazonium salts. This is a very easy topic, in fact the easiest topic of organic chemistry. It has a general formula of RN2X. This is the structure. It will have an N2 plus group. This is known as diazo group. N2 plus group is known as diazo group. If we have C6H5N2Cl, then it is known as benzene diazonium chloride. If we have HSO4 minus, then it is known as benzene diazonium hydrogen sulfate, and so on. Let us now talk about the preparation. Preparation is very simple. It is prepared by a technique that is known as diazotization. Now what is diazotization? In diazotization we are taking aniline, treated with NaNO2 and HCl at a temperature of 273 to 278 Kelvin, and we are getting the benzene diazonium chloride and NaCl and water over there. So this is how we are preparing the benzene diazonium chloride, and the process is known as diazotization. Let us now talk about the physical properties. Very simple. It is a colorless crystalline solid. It is readily soluble in water and is stable in colder conditions, but with warm water it is reactive. It decomposes easily in the dry state. Benzene diazonium fluoroborate. This is important. That is, we have this compound N2BF4. This compound is water insoluble and it is stable at room temperature. So that is an important point, exceptional point. So this is an exceptional point. This compound is stable at room temperature and it is insoluble in water. Other all are soluble in water. Let us now talk about the chemical reactions. Very easy. First one is we have to substitute it with the chlorine. So if we have to carry out, that means if we have to substitute this ArN2X to form ArCl, then we have to carry out Sandmeyer's reaction. Now Sandmeyer's reaction, what we have to take, in the case of Sandmeyer's reaction, either we can take CuCl2 in the presence of HCl, then we'll be getting Cl substituted in the benzene ring, we'll get this compound. If I am taking CuBr in the presence of HBr, then Br will get substituted over here, and if you take CuCN in the presence of KCN, then Cn will get substituted over here. So it's a very simple reaction that is known as Sandmeyer's reaction. Now another one is Gattermann reaction. In Gattermann we can substitute either chlorine or bromine but not cyano group. So here what we have to do, we have to take copper in the presence of HCl. Here we took CuCl in the presence of HCl, but here we have to take Cu in the presence of HCl, or Cu in the presence of HBr. We will get Cl or Br substituted over here. Let us now talk about replacement by iodide ion. We can take ArN2Cl treated with Ki, we will be getting ARI over there. That means we get iodobenzene. So this is another simple reaction. So the importance of diazonium compounds is that they can be used for the preparation of many other compounds in laboratory. So it's very useful. Next one is preparation of fluorobenzene. Here you can see, first we have to treat it with HBF4. We are getting ArN2BF4, and that on heating will release us BF3 and N2, and whatever is left we have to join to get ARF. So this is another simple reaction. Next is replacement by hydrogen. We can treat it with H3PO2, we get benzene over here, or we can treat it with alcohol, ethanol, there also will be getting benzene. Next is the replacement by hydroxyl group. There we have to treat it with water, we will be getting AROH, that is phenol. And the last one is replacement by NO2 group. There we have to treat it with HBF4. Then we will be getting this compound. This I have already told you, it is insoluble. And then we have to treat it with NaNO2 in the presence of copper. So we will be getting NO2 over here. Now let us talk about coupling reactions. Coupling reactions is very simple. We have to remove one H from here and Cl from here. Write down the molecules together. Remove an H from here, Cl from here. Here also we have to remove an HCl. And whatever is left we have to join. So if we are treating it with phenol, then we will be getting an orange dye because of para-hydroxyazobenzene. And if you are treating it with aniline, we will be getting para-aminoazobenzene, which is responsible for a yellow dye. So this is about coupling reactions. So with this, we are concluding this chapter, and now let us do the questions related to this chapter. So let's do this question. Which of the following is a tertiary amine? So it is triethylamine. Sorry, primary amine is asked over here. So it should be triethylamine, because what is the structure of triethylamine? We have CH2CH3, CH2CH3, and another CH2CH3. This is the structure of trimethylamine. So answer should be option number 2. Next question. Amongst the following, the strongest base in the aqueous medium is? What should be the answer? It is aqueous medium, right? It is aqueous medium, and it is also saying that it is, all these are methyl substituted. 3 are methyl substituted, but one is, yeah, all are methyl substituted and one is aryl substituted. So if we take this third one, that should be the answer. This is the most basic, because we have studied that S is the most basic, right? STP will come in the case of ethyl substituted, and SPT will come in the case of methyl substituted. So anyway, secondary will be the most basic, so it should be option number 2. What is the correct IUPAC name? So you can try this now. It should be N-methyl prop 2-ene 1-amine. Option number 4 is the answer. Let us now move on to the next question. Which of the following is a weak Bronsted base? So here we have to understand that aniline is the weakest Bronsted base among the given compounds because of resonance. Resonance is present. So since resonance is present, the lone pair is less available for the donation to the acid, and as a result of which it is going to be the weakest Bronsted base. Let us now talk about the next question. Benzyl amine may be alkylated as shown in the following equation. What is the mechanism that is followed? Sorry, which of the following alkyl halide is best suited for this reaction through SN1 mechanism? So SN1 mechanism, as you could remember, is through the formation of carbocation. It is following carbocation mechanism. So we have to find which one can form the best carbocation, the most stable carbocation, and that can be formed by third one. So that should be the answer. Next question. Which of the following reagents would not be a good choice for reducing an aryl nitro compound into an amine? So what could be the answer for this? First one we can use, it's a good reagent, but second one is not a good reagent. It cannot be used for the conversion into ether. No reaction will occur in the presence of LiLH4 in ether. So the answer should be option number 2. Let us move on to the next question. In order to prepare primary amine from alkyl halide with simultaneous addition of one CH2 group in carbon chain, the reagent used as a source of nitrogen is? So the answer is potassium cyanide, KCN, because we have a compound like this. So this have to be first treated with KCN. So we will be getting CN, and now we can treat it with sodium in ethanol. We will be getting a primary amine over here. NH2 over here. Next one. Source of nitrogen in Gabriel thalamide synthesis. What will be the source of nitrogen? Source of nitrogen will be potassium thalamide. Option number 4. Let us now talk about the next question. Amongst the given set of reactants, the most appropriate for preparing secondary amines is? What could be the answer for this question? It should be third one. Third one is the better method for preparation of amines. We are taking a primary RNH2 plus RCHO. So that time we will get an imine, and then we have to treat it with hydrogen in the presence of platinum. We will be getting a secondary amine. So that is the best method of preparation of amines. We have to prepare secondary amines. So that is the best method. Let us now talk about the next question. The best reagent for converting 2-phenyl propanamide into 2-phenyl propanamine. Propanamide should be converted into propanamine. So that can be converted. It's a corresponding series. It's not ascent or descent. So it should be lithium aluminum hydride in ether. Best reagent for converting 2-phenyl propanamide into 1-phenyl ethanamine. So that should be a descent of series. For descent of series, we can use Hofmann bromamide degradation reaction. So the answer should be option number 2. Hofmann bromamide degradation reaction is shown by amides only. So it should be option number 2. Next question. The correct increasing order of basic strength for the following compounds is, most basic is going to be when there is a CH3 group, right? Releasing group will, or we can say donating group will increases the basicity. So 3 will have the maximum. So only one option is coming, that is option number 4. Next, methylamine reacts with HNO2 to form. So what is it going to form? It is going to form an alcohol, right? We have studied that in Lieberman's nitroso test, a primary amine is going to form an alcohol and the secondary amine is going to form a diazonium salt. So here the answer should be option number 3. Next one. The gas evolved when methylamine reacts with nitrous acid is. Methylamine is reacted with nitrous acid, so we will be getting nitrogen gas in the process. Option number 2. In nitration of benzene using a mixture of concentrated H2SO4 and concentrated HNO3, the species which initiates the reaction. What is the reaction that is happening? The reaction that is happening is electrophilic substitution reaction. So electrophile should be generated and the electrophile is NO2 with a positive sign. Nitronium ion. So answer should be option number 3. Let's see this question now. Reduction of aromatic nitro compounds using iron and HCl is. So what could be the answer for this question? Reduction of aromatic nitro compounds will give us aromatic primary amine, right? So it should be option number 3. Most reactive amine towards dilute hydrochloric acid. Towards dilute hydrochloric acid, it should be a tertiary amine. So that is important. It is following the order tertiary greater than, secondary greater than, primary. So greater the base strength of the base, greater will be its reactivity towards dilute HCl. Next, acid anhydrides on reaction with primary amines. What will it give? It will give us amide. Next reaction. Next question is the reaction ArN2Cl in the presence of Cu and HCl will give us ArCl plus N2 plus CuCl. This reaction is known as Gattermann reaction. Best method for preparing primary amines from alkyl halides without changing the number of carbon atoms in the chain. What should be the answer? Without changing the number of carbon atom, we have to prepare primary amines. So we can use Gabriel thalamide synthesis. Hofmann will give descent of series. And this is not used for the process of preparation of amines. Which of the following compounds will not undergo azo coupling reaction with benzene diazonium chloride? So here, if you look at the first one, it will. Second one also will undergo. Third one also will undergo, but nitrobenzene will not undergo the coupling reaction. That is an important point. Nitrobenzene will not undergo because diazonium cation is a weak electrophile. It's a weak electrophile, diazonium ion. Electrophile is weak in diazonium ion. So electron rich compounds can react, but electron withdrawing group will not undergo coupling reactions with this weak electrophile. So that is an important point. Now the last question, which of the following compounds is the weakest Bronsted base? The weakest Bronsted base in the following is, it should be option number C. Phenol is the weakest Bronsted base because after losing H plus, it will produce the least stable conjugate acid among all these. So that should be the weakest Bronsted base. So the answer should be option number 3. With this, we are concluding this chapter and also we are concluding this series. Hope you like this series. Please do share, like and comment below your queries and your suggestions so that we can come up with new series like this in future as well. So thank you and have a great day ahead and stay home, stay safe. Happy learning.